Okay, let's go back to this very simple example, but there are a lot of information over here. Okay, now the self-adjoint, I use L if this boundary condition on U, I would say the other way. Okay, if the boundary condition G, okay, the boundary conditions, they are the same as the boundary condition of U. U of 0 and U of 1, this is given. So this is a consequence such that I will impose the self-adjoint, okay? Now, these are what I did before, okay, no problem. Now, I want to solve, okay, for G sub R and G sub L, okay? Now, you see, the behavior of G, okay, for t greater than x is different from the behavior of G for t less than x, okay? Because from this discontinuity, and because the the Dirac delta, okay? Now, you see the limit of x is between 0, okay, and 1. That's why this integral here is from 0 to 1. You see, G satisfies, okay, that's very important, at x 0 and 1, okay? When I plug the boundary condition 0x, okay, I have to impose this condition on GL. That's important. When I apply the boundary condition at t is equal 1, I must substitute here 1 on the G right, okay? They are completely different, but the GL, G sub L, G sub I are continuous at this point over here for t is equal x. But it is discontinuous, okay, when t is equal x, which I showed right here, okay? Now I will erase here, okay, this here. I just left just for you to understand that I will have four conditions, okay, 4 conditions to find out the 4, let me say constant, because the coefficient, they are function of x, okay, you see it, okay, quite clear. Now I'll erase here, okay, this is not good because I left some dirty here. See, I'll use a better one, okay, just to erase this here. Okay, look. I'll clean this. Okay. Now let's solve. Okay, I'll show just clearly what I'm doing here. Okay, look. Let's see these 4 conditions. Okay, look. The second derivative of t with respect to t at 0, this means that g is a function of C1 and C2, okay? That's a polynomial of the first degree, okay? Now, okay, if t is less than x, so I have GL, okay? GL is for t less than x. And G right, okay, for t greater than x, okay? This is a G right and G left, okay? Now, why t and x? Because you see that this coefficient here, okay, that they were obtained from the homogeneous, okay? You see that A1, A2, B1, B2, in general, they are function of x. X is the fixed point. It's very important, okay? You see it here, okay? So that's why G is a function of t and x, okay? Now, I will impose those 4 conditions. Quite easy, okay? Look, GL is A1 plus A2t. G right is b1 plus b2t. So this coefficient, which they are function of x, we don't know. But as I said before, we have 4 conditions. Okay, the first one, t is equal 0. Look, t is equal 0. I have to look at this left over here. Okay, forget the right. Okay, the t is equal 0 reach GL, not G right. So GL, okay, at t is equal 0 will be 0. So look, it's quite easy. Okay, just set here t is equal 0. Okay, then I will have a1 plus 0 a2. This is equal 0. So that's the first condition. The second condition, t is equal 1, okay? I cannot use GL. I have to GR because 1 belongs to t greater than x, okay? That's why I plug here for t is equal 1, GR is equal 0, okay? Right here. So this case 0 is equal b1 plus b2 because t is equal 1. I'll put here times 1, okay, just to be clear. Okay, now the third condition, it is continuous at t is equal x, so no problem. If t is equal x, gr is equal gl, so a1 plus a2x is equal b1 plus b2x because t, you see, t is equal x. Okay. The fourth condition, I just erased it there, okay, is derivative. Okay, derivative of gr respect to t, look, gr respect to t is b2, and derivative of gl with respect to t is a2. So this is a difference. b2 minus a1 is 1 divided by p of x. Do you remember? Look at this equation here. Here is p of x, which is a2 of x. Okay? This is 1. So I divide 1 by 1, this is 1. So I have a fourth condition. b2 minus a2 is equal 1. Okay, let's solve this. Okay, let's solve this. I'll put here. So look, a1 plus 0 is equal 0. So a1 is equal 0. See? Now here, b1 plus b2 is equal 0. So b1 plus b2 is equal 0, which implies that b1 is equal minus b2. That's the first condition, that's the second condition. Let's go to the third one, okay? The third one, at t is equal x, the function is continuous. So this gr is equal gl at t is equal x, okay? So I'll write down here a1 plus a2x is equal b1 plus b2x. That's the third condition. And the fourth condition, okay, b2 minus a2 is equal 1. So b2 minus a2 is equal 1. So I have 4 parameters, okay, to find out, to get, and 4 equations. That's quite easy. Okay, let's do as follows, okay? Look, b1 is equal minus b2. a1 is 0, okay? Let's put a1 here, okay? This is 0, okay, from here. So, b1 is equal minus b2. Let's maintain a2x, okay? a2x is equal, b1 is minus b2, so I have minus b2 plus b2x. This is equal, in this case, B2 that multiplies x minus 1. Okay? So A2x is B2x minus 1. Now, B2, okay, is equal minus A2. Oh, that's plugged there. So A2x is equal B2 is 1 plus A2, just from here, look. B2 is equal 1 plus A2. I just substitute over here, this is x minus 1, okay? Now, A2x is equal, let's put here, x minus 1, here, A2x minus A2, you see? So, let's go. I simplify this and this. So here, A2 is equal x minus 1. You see? Just plug A2 on the left-hand side. A2 is x minus 1. Okay, A2 is x minus 1. You see? I can get, let's see here, look, let's plug A2, A1 is 0, okay, A1 is 0, okay, so from here I just obtain, okay, GL, easy, okay, because A1 is 0, A2 is x minus 1 t, so I'll write down here, look, GL is equal, A1, okay, is 0, plus A2 x minus